Welcome to the Agentic AI podcast. Today, we're doing a deep dive into probably the biggest infrastructure headache facing enterprise IT right now, the rise of agentic AI.
Yeah, it's definitely moving fast.
It really is. We're not just talking theory anymore. These
Yeah.
agents, they're shifting from research papers into actual operational systems. And that's putting intense, really new demands on the cloud and network setups we already have.
It's a huge paradigm shift. I mean, you really have to understand how different agentic AI is from what came before to grasp the scale of this infrastructure challenge.
Okay, so let's break that down. What came before?
Well, first you had traditional machine learning. Think predefined rules, static data sets, mostly for predictive tasks like basic fraud detection.
Right, useful, but kind of a black box. You put data in, you get a prediction out. Pretty contained.
Exactly. Then generative AI, or Gen AI, arrived. That's all about content creation, text, images, code, mainly following human prompts.
Still requires a human in the loop, essentially.
Pretty much. But agentic AI, that's the leap. These are autonomous systems. They're designed to pursue objectives.
Objectives, okay.
Yeah, they do complex planning, make decisions independently, execute actions, all with minimal human oversight, adapting as they go. They don't just predict or create on command, they act.
Okay, right. That independent action piece. That's why CIOs and cloud architects probably need to be, well, maybe not panicking, but definitely rethinking budgets now.
Absolutely. The projections are stark. Something like, nearly 80% of organizations could be impacted by agentic AI by 2026.
2026, that's basically tomorrow in IT planning terms. It's not a 5-year roadmap issue. It's next year's budget cycle.
Precisely. Which forces a proactive design focus on, I'd say, 3 main things immediately: handling massive concurrency, achieving near zero latency, and seriously beefing up security.
And that urgency really comes from how these systems are built, right? Gen AI scaled up cloud use, sure, but agentic AI changes how the cloud gets used.
Completely. The big strain starts with multi-agent systems collaborating. Imagine hundreds, maybe thousands of agents all coordinating, sharing information, working towards one goal. Most of that data isn't just going in and out of the data center anymore.
That's the classic east-west traffic problem, but on steroids. Data moving sideways between servers inside the network, that wasn't usually the bottleneck.
But it is now, or it's becoming one, fast. And that collaboration just eats up resources. So what are these agents actually doing that's so demanding? It's kind of a triple threat to your infrastructure.
Okay. Threat number 1.
Continuous context windows. Unlike a simple prompt response, agents need ongoing memory. They need persistent state and a ton of bandwidth to keep track of multi-step tasks over time.
So they can't just forget what happened 5 minutes ago or what another agent just told them.
Exactly right. Second threat, they rely heavily on external data, often proprietary enterprise data. They use retrieval-augmented generation RAG pipelines constantly.
AG. So they're always checking facts against real-time data feeds, internal databases, ticketing systems.
Constantly. It's how they ground their decisions in reality, in your company's specific knowledge. It stops them from, making stuff up or acting on bad info. But it means continuous data pools.
Okay, continuous context, continuous data pools. What's the third threat? It must be the sheer volume this creates.
You got it, the volume of interactions. Agentic AI might need up to 10 times more API calls than a similar Gen AI task.
10 times.
Yep. And if these autonomous agents aren't governed properly, if the orchestration is weak, you get prompt storms or endless loops really quickly.
Sounds like a self-inflicted DDoS attack. 100 bots just hammering your own APIs because they're stuck.
That's exactly what it can be. The operational impact, the cost impact, it's immediate. Think about supply chain optimization as an example. It's not one AI running a batch analysis anymore. It's a swarm of agents. One monitors inventory levels, another's predicting shipping delays, a third is maybe adjusting supplier orders on the fly, a fourth updates pricing, all at the same time.
All talking to each other, hitting APIs.
Simultaneously. Constantly. That kind of continuous parallel action is what breaks older infrastructure models.
Okay, this brings us squarely to the network implications. If decisions are real-time, latency becomes absolutely critical. We're talking sub-millisecond connections, right?
It's the new baseline, yeah. Traditional ML could handle batch delays. But an agent deciding to, say, halt a rogue financial trade Or reroute a critical shipment based on live data needs instant response, sub-millisecond.
And that's even more critical in distributed setups, like edge computing.
Especially there, or with 5G-enabled devices where the agents are physically distant from the core systems.
You mentioned 5G. It's not just about speed, is it? It's about managing the connection itself.
Yeah, specifically 5G network slicing. It lets providers carve out dedicated, guaranteed bandwidth just for those critical agents out at the edge. Think robots on a factory floor or smart traffic grids.
So they get a clear, low-latency line back to base, no matter what else is happening on the network.
Exactly. It ensures that consistent connectivity. But back inside the data center, that API traffic explosion is still a huge issue. It's not big, heavy requests. It's millions of tiny microtransactions agents messaging each other.
How do you even manage that effectively? Your standard load balancers might struggle.
They definitely struggle. Those tools were built for simpler north-south traffic user talking to server. For this complex agent-to-agent chatter, the east-west stuff, you really need service meshes.
Okay, explain service meshes a bit more. Why are they the answer here?
A service mesh acts like a dedicated traffic cop layer just for service-to-service communication. For agents, it provides structured, observable, and secure messaging. It handles tricky things like smart routing, automatic retries if a message fails, encryption for every little interaction.
So it stops it from becoming unmanageable chaos.
Pretty much. Without it, those thousands of rapid-fire agent messages quickly turn into spaghetti. Total nightmare for stability and debugging.
And all those microtransactions.
Yeah.
That must dramatically increase the security attack surface too. Agent autonomy is the goal, but it sounds like it's also the biggest risk.
It's the double-edged sword, isn't it? An agent built to act on its own is also perfectly placed to cause damage if it's compromised or goes rogue.
So the security model has to change fundamentally, from protecting human logins to protecting every single software agent.
That's the core shift. How do you secure something designed to operate independently, maybe for days without human checks? It means much more advanced security than just firewalls.
Or we're talking about giving each agent its own verifiable identity, like a digital passport.
Essentially, yes. Robust identity management for every agent, unique credentials, tokens. You also need meticulous data lineage tracking.
So you can trace exactly how a decision was reached, which agent saw what data when.
Precisely. And critically, you need zero-trust architectures, specifically designed for agents.
Zero trust, meaning you don't automatically trust anything, even inside the network.
Right. But for an agent, it means continuous dynamic verification of every action, every communication attempt. Trust isn't granted once. It's constantly reevaluated based on behavior and context, much stricter than a human logging in once.
And observing these autonomous things must be a huge challenge too. How do you spot subtle problems before they blow up?
That's the observability piece. Detecting weird behavior, or worse, those signs of a coming prompt storm, like agents looping, making pointless calls, needs really sophisticated monitoring.
What kind of tools?
We're seeing integration with things like network digital twins, basically a live virtual replica of your network.
So you can simulate agent interactions there first, predict problems.
Exactly. Model the impact in the twin before it takes down the real system. It's about predictive analysis for agent behavior.
Okay, shifting gears to the cloud side. The big issue with agentic AI seems to be unpredictability.
Extreme unpredictability. Yeah. Old AI workloads, often fixed compute for training, or maybe predictable inference patterns. Agentic AI. Totally different beast.
How so?
Agent workloads scale based purely on the task complexity at that moment. An agent might be doing very little, then suddenly a major event happens, a market crash, a supply chain disaster, and it bursts into massive activity instantly.
Which demands truly elastic compute and memory. It needs to scale up and down on a dime.
Right. And if you just provision for the absolute peak demand all the time, your costs go through the roof when it's idle.
But if you under-provision, the agent fails just when you need it most. Tricky balance.
Very tricky. That's why things like serverless architectures or GPU pooling become so important. They let you handle those unpredictable bursts more efficiently.
Paying only for what you use when you use it.
Pretty much. It avoids massive over-provisioning costs. Which brings us to the other side of that prompt storm coin. Cost optimization.
Ah, yes.
Yeah.
Ungoverned agents making 10x the API calls isn't just a stability issue, it's a massive budget killer.
It can absolutely sink you. That excessive usage isn't just raw compute. It's network egress fees, charges per API call, database lookup costs, all multiplied by that potential 10x factor.
You gave the example of a finance agent stuck in a loop.
Yeah, imagine it hitting external data providers hundreds of times a minute for hours, trying to find an exchange rate it already found. The bill for just that data access could be crippling. So governance and cost control are completely intertwined here.
Makes sense. And this volatility, plus the need for compliance in some areas, that probably explains why hybrid and multi-cloud setups are becoming key for agentic AI, right? You can't just dump everything in one public cloud basket.
A hybrid approach often makes the most sense, yeah. It lets you keep sensitive workflows, things touching protected health information, or core financial data securely on-premise under tighter control.
While offloading the really bursty, unpredictable stuff to the public cloud for cost efficiency.
Exactly. Use the public cloud for its scalability and elasticity where it makes sense. Plus, agents often need to tap into huge SaaS ecosystems, which live in the cloud. But managing data sovereignty and secure interoperability across all those environments, that requires really robust, overarching governance.
Let's make this more concrete. Can you give some specific industry examples? Where are these infrastructure pressures showing up in real applications?
Sure. Look at telecoms. Huge impact in autonomous network optimization. Agents analyze network performance in real time, adjusting things like bandwidth allocation conversationally.
Conversationally.
Yeah, like optimizing radio access networks, the RAN, using platforms running on, say, AWS infrastructure. The goal is level 5 autonomy, where the network basically manages and heals itself.
Wow. Okay, what about finance? Security and compliance are king there.
Finance is using agents heavily for compliance automation, things like Know Your Customer, KYC, and anti-money laundering, AML checks.
Automating that paperwork trick.
And making it dynamic. Agents running constantly in secure, regulated cloud environments can analyze transactions against risk rules and adapt immediately to new regulations much faster than humans can review manuals.
In healthcare, with the two constraints.
There, agents are helping streamline patient flows and allocate resources, beds, staff, equipment. They operate in super secure environments like HIPAA-compliant Azure setups. They can predict surges in admissions or resource shortages, hopefully improving care while keeping data locked down through strict, verifiable access controls.
Okay, so the demands are clear, the risks are real, the costs can be scary. For the IT leaders and architects listening, what's the practical checklist? What upgrades are non-negotiable right now?
On the network side, definitely look at upgrading to SD-WAN for smarter routing. Implement 5G slicing if it fits your use case, especially for edge deployments. And crucially, plan for edge AI nodes to get processing closer to the action and beat latency.
And in the cloud, what needs to change there?
Architecturally, prioritize containerization, usually Kubernetes, for portability and scaling. You absolutely need to implement service meshes for managing that inter-agent communication. And invest in efficient GPU pooling to handle the resource bursts without breaking the bank.
But underlying all of that, tech governance.
Absolutely essential, non-negotiable. You need dedicated AI workload monitoring dashboards that show you what agents are doing and costing. You need hard cost control rules and budget limits. And you need meticulous compliance logging for every single agent action.
Are there tools emerging to help manage this complexity?
Yes, thankfully. We're seeing more agent orchestration platforms, some even with no-code interfaces. They aim to simplify the integration, security, and governance aspects, connecting agents safely to existing enterprise systems.
So if we summarize the technical leap, agentic AI compared to older AI is wise.
Way higher latency sensitivity, very high.
Yeah.
Much more unpredictable scaling needs highly elastic. And demanding advanced security, that dynamic zero trust model we talked about, it's a stark difference.
Really highlights the transformation.
It really does. Agentic AI is fundamentally reshaping how enterprises operate, top to bottom. It demands infrastructure that's adaptive, super secure, and massively scalable. Investing in those upgrades now, that's about positioning yourself to actually use this next wave effectively, not just cleaning up the mess later.
The message seems clear then. Assess your current infrastructure's readiness for agents, start piloting hybrid or multi-cloud approaches to manage the volatility, and get serious about implementing zero-trust security across the board today.
Preparedness really is key for this shift.
So as you're listening, think about this. What core business processes are you considering handing over to autonomous agents? And crucially, have you really mapped out the cost governance strategy? How will you prevent one of those crippling prompt storms where ungoverned agents just run wild with API calls? Because remember, that threat, that loop of runaway consumption, it's as much a governance problem as it is an infrastructure one. Something to think about.